Hello everyone, welcome back to another video. And in this video, we're going to be taking a look at a paper 2 question, and this is from an HL paper from the November 2020 batch. So this is a part of question 1, and this is the C subsection of question 1 in the chemistry paper 2. So they've asked us, chlorine gas reacts with water to produce hypochlorous acid and hydrochloric acid. And then they have told us, first part, hypochlorous acid is considered a weak acid. Outline what is meant by the term weak acid. Now, I'm going to give you the simple, straightforward definition of what a weak acid is and what you should write. It is literally one sentence and it is super easy to remember. What is a weak acid? A weak acid is an acid which partially ionizes or dissociates in an aqueous solution. So AQ basically stands for aqueous. So they said that weak acid is an acid which partially ionizes or dissociates in an aqueous solution. That is the definition of a weak acid. But what does this mean? What are all these terms? What is the meaning of partial ionization? What is full ionization or dissociation? What is all of this? You may be a bit confused. So I'm going to clear that up for you. So basically, dissociation in chemistry is essentially when a molecule splits into smaller atoms or ions or molecules. So basically breaking apart into smaller pieces. That's basically what dissociation is. You can even if you are aware of the vocabulary, you know that to dissociate something, to break something into smaller pieces, right? So that's dissociation. So if a weak acid ionizes or dissociates partially, what does a strong acid do? Well, a strong acid, you may have guessed, dissociates completely in an aqueous solution. And this aqueous solution is typically, it's of course water, right? When you dissolve an acid in water. So I'm going to give you an example of what I mean. So what is dissociation? I'm going to show you a dissociation between a weak acid and a strong acid. So this is a dissociation for a strong acid. I'm going to take the example of HCl, which is very common. Everybody knows it. Hydrochloric acid, it's a strong acid. So hydrochloric acid, now we're going to put it in water because remember, this is aqueous solution. We put it in water. And this gives us Cl minus plus H3O plus. And you can see that over here, of course, this HCl has acted as the Bronsted-Lowry acid, and it has donated its hydrogen to H2O, and H2O has then formed H3O, which is the ion, and Cl minus has become the conjugate base because it has donated of its hydrogen to H2O. Now, how do you tell this is a strong acid? What is the meaning basically of a strong acid? So what it basically means is, if I have a solution, right? If I have a solution and inside the solution, I have 100 inside the solution, I have 10 HCl molecules, right? I have a very small beaker of this acid, and inside the beaker, I have 10 HCl molecules, okay? I'm not going to draw all 10 of them, but over here we just have 6 because I'll run out of space. Now, each and every single one of these HCl molecules, every single one of them, I mean, right? When they react with water, all of them are going to dissociate. They are all going to dissociate. That means this is what they're going to form. They're all going to break apart when they react with water. So you can be rest assured that when you dissolve HCl in water, this reaction is bound to happen, and this will happen for every single HCl molecule in that beaker of acid. And that is what is the meaning of full dissociation. Every single molecule of HCl dissociates or breaks apart. And you can see it happening. You can see the breaking apart happening over here. HCl is being broken apart by water into Cl minus and H plus. And then water consumes this H plus to form H3O plus, right? Because this is the first step. First, it breaks apart into H plus and Cl minus, And then water is pretty greedy. It consumes this H plus to form H3O plus. So for every single molecule or every single molecule of the acid in a strong acid, when it reacts with water, it will completely dissociate every single molecule. Now, in comparison, let's look at what will happen to a weak acid. Okay, let's look at what will happen to a weak acid. Let me just erase all of this real quick. So, what will happen to a weak acid? Like I said above, a weak acid partially ionizes or dissociates in an aqueous solution. So what is a weak acid? I'm going to take a quick example. The most common example is ethanoic acid. So ethanoic acid looks something like this. So this is ethanoic acid. So when I'm going to react this ethanoic acid with water, it is also going to do something similar like HCl did, right? Water is going to form H3O plus, and ethanoic acid is going to become Ca3 minus because, well, this has lost one of its hydrogens basically. CH ethanoic acid has donated one of its hydrogens to water, and it has acted as a Bronsted-Lowry acid. Water acts as a Bronsted-Lowry base and accepts these hydrogens, and there we go, you have your products formed. So the exact same thing happens over here, but then you notice this little reversible sign over here, right? This is a sign to indicate that the reaction is reversible. And why do we say that it's reversible? What does this even mean, right? What is the meaning of partial dissociation? Now, like I mentioned to you earlier, if I have 10 molecules of HCl and I react all 10 of them with water, all 10 of them are going to dissociate or break apart. However, if I have the exact same case with ethanoic acid, if I have 10 molecules of ethanoic acid, okay, into 10 to make things easy for me, okay, if I have 10 molecules of ethanoic acid, only 5 of these, for example, only 5 of these are going to form CH3COO minus. Only 5 of these are going to dissociate. That's why we say partial dissociation, not entire, partial, right? So out of 10, only 5 have dissociated, while the other 5 remain how they are. They don't want to dissociate, or they don't dissociate, right? This is a weak acid. It doesn't want to dissociate, and it doesn't, and consequently, it doesn't do that. 5 of them don't, 5 of them do. So you could say they're partially dissociated, right? Not all of them have dissociated or broken apart. And that is exactly what the definition also says. It's an acid which partially ionizes or dissociates in an aqueous solution. So hopefully I've explained the difference between a weak and a strong acid, and hopefully you're able to conceptualize what is the difference and what is partial dissociation, what is full dissociation, what is a strong acid, what is a weak acid, so on and so forth. So we can write our definition over here. I am just going to use my my superpower that I have, and I'm going to carry this entire thing up, and I'll just put it there. Here we go. And this definition should get you the 1 mark that you need. So it is an acid. Oops. It is an acid which partially ionizes / dissociates in an aqueous solution. But remember, in the exam, please write the full form of aqueous. Don't just write AQ, because I've just written it because it'll save me space. But you should do the full form. Don't leave anything in short form unless they've asked you to. Now, let's move on to the next part. State the formula of the conjugate base of a hypochlorous acid. Now, all of you guys, I'm sure you're familiar with what a conjugate base is. If you don't know what a conjugate base is, I have done a video on it earlier. So please go and watch that. But a conjugate base, to summarize for you, is basically the base or the product formed once an acid has given off its hydrogen. So for example, we saw that CH3COOH, ethanoic acid, when reacting with water, and if it partially ionizes, we get CH3COO minus. This is the conjugate base. Once it's given off this hydrogen to water, we get this is the conjugate base. So in hypochlorous acid, which is HClO. If HClO gives off one of its hydrogens, well, what will it form? What will be the conjugate base? Well, it will be ClO minus. Simple as that. That's all you needed to know. That's it. That's the conjugate base. Next part. Calculate the concentration of H plus in a HClO solution with the pH of 3.61. Now, I'm sure all of you are quite familiar with how to calculate pH if you have the concentration of H plus. You just do negative log of the concentration of H plus, right? And then you will get the pH. But now they have given you the pH and they're asking you to calculate the concentration. So we know the pH, right? This is equal to pH. But now we know the pH. Basically, the pH is equal to 3.61. And they're asking us to calculate what this is. And how do you do that? Well, it's very, very simple. If you want to calculate the concentration of hydrogen from the pH, just raise the pH to 10 to the power of negative 3.61. That is simply the formula. So basically, in short, this is your key to finding the concentration of H plus from the pH. It's 10 to the power of negative pH. And in this case, it will be 10 to the power of negative 3.61. And this gives us an answer of 2.5 times 10 to the negative 4 mole dm cube. Never forget the units, please. That'll be a very silly mistake or very silly way to lose marks. So that is it for this video. I hope that you've understood the concept of conjugate base, weak acid, how to calculate H plus from pH and vice versa. I hope you've understood all of that. It's a very important concept to learn, comes up a lot in papers, both paper 1 and 2. And hopefully you've also enjoyed the video. Thank you so much for watching. If you have any questions regarding this concept or any other concept, please feel free to reach out to me on my social media, email, or comments, put it down in the comments below. You know, I'm always open to questions and I'm always answering them. Thank you so much for watching. See you in another video with a brand new question.